Hi everyone, so this is Haley and our second video is going to be on determining the E of cell. So for our first problem, what is the value of E standard for the following balanced reaction? So in this case, which formula are we going to use in order to find E of cell? So we can use the E of cell formula, that's E standard, and that's equal to 0.0592 divided by n, so this is number of electrons, number of moles of electrons, to log of K, because we're given the K value. So in this case, we can plug in everything, so that's E cell. Let's plug in what we know, so we know what K is, but we have not found out what N is yet. So 4.38 times 10 to the positive 10. And now we have to find the moles of electrons transferred. And since the reaction is balanced, you could probably look at this reaction without breaking it down to the half equations in order to find out how many electrons are transferred. But in this case, I will do both of the half reactions for clarity. So Zn goes to Zn2 plus, and Fe2 plus goes to Fes. And in this case, we can see that for the zinc reaction, our electrons should be going on the right side, and the electrons that we need would be 2, and that for our iron reaction, we want our electrons to be on the left side, and that would also be 2, right? Because we want both of our sides of our equations to have the same charge, so that would be 0 on the left side and 0 on the right side. And we can add 2 electrons to make this occur. In this case, we want to make sure that our electrons in the top reaction match the number of electrons in our bottom reaction. And we can see that this is also true because they are both 2 electrons. And in this case, 2 electrons is actually the number of electrons transferred. So this is also the moles of electrons transferred. And we can plug that into our E of cell. So 592 over 2 log of 438 times 10 to the 10. And in this case, we can get our value, which is going to be positive 0.315 volts. All right, so that should be a standard question for an E of cell. And in this case, we can do one more with the same equation. So what is the value of K for the following balanced reaction? And in this case, they're giving you E of cell. So if we use the same equation, E cell equals 0.0592 n log K. We can rearrange this equation in order to get K by itself. So that would be K is equal to 10, base 10, to get rid of the log, and E cell all over 0.0592. And in this case, now we just have to plug in E of cell and N. So K is equal to 10 N. We haven't found N yet, but we know that E of cell is 0.0218 volts, and that's over 0.592. In this case, in order to find N, again, we can just look at the equation because we know it's balanced. In this case, I'm going to do the half reactions just so we can also see how that works. So we have 3ZnS, and that goes to 3Zn2 plus, as well as 2Cr3 plus, going to Cr in its elemental form. This should actually be a 2. And in this case, how many electrons are transferred? So for the top reaction, we can see that we need 6 electrons on the right side. And for the bottom reaction, we can see that 2 times 3, we also need 6 electrons. In this case, our electrons are equal again, and we can see that 6 electrons are transferred. So 6 moles of electrons are transferred. So in that case, K is going to be 6 as our N, 218 over 0.0592. And we can see that our K is going to be equal to 162. So for our last question, we have what is the value of Ecell for the following balanced reaction? And in this case, this is not E standard cell. It doesn't have the degree sign, which means it's a standard reduction potential. Instead, we have to see that this is going to be based around the concentrations of our ions in solution. And in that case, we have to use a different equation that has both of these concentration values incorporated into it. And in that case, we can use the E of cell is equal to the E standard of the cell minus 0.0592 over N. Of course, that's the number of moles of electrons. And this time we have log of Q. Q being our substitute for K, Q being K at any temperature and any concentration. In this case, we can substitute what we know. We know our E of standard, so that's E 1.260 volts. And now we just need to find our N and our Q. In this case, we can find N by, of course, looking at the equation, as I said before, but also creating its half reactions. So that's AlS to 2Al 3 plus, as well as 3 cadmium 2 plus to 3 cadmium solid. And in this case, we can see that we need to add 6 electrons to this side and 6 electrons to the left side on the bottom reaction. And in this case, the 6 electrons are equal, so we need 6 moles of electrons transferred, so N is 6. Now we have to look for Q. So remember, Q is just products over reactants, and it's the concentrations of both. So in this case, we can look at our products and see that our Q would be Al3 plus to the second, so that's squared because of the 2 coefficient, as well as the CD, the cadmium is a solid, so it would come out as 1 in this reaction. I mean, 1 to the third if we're really keeping track. And then on the bottom, we have products, and products would be cadmium in the solution. So that would be to the power of 3 because of the 3 coefficient again, and aluminum, which seems to be in a solid form. So that, of course, is just 1, and we can put the 2 if we deem it's necessary. So in that case, our Q, when we add everything in, our values, we can see that it's going to be 0.06 moles over 0.1 moles. And the top one is going to be raised to the second. The bottom part is going to be raised to the third. And in this case, we would get 0.36 and 0.001, which is going to end up with 360 as our Q value. So we can plug this into our E of cell equation. So that's E of cell equals 1.26 volts to it should be minus, so volts minus 0.0592 over 6, which is our N, and then log of 360. So in this case, our E of cell will be equal to 1.23 volts. All right, so that's it for this video. If you have any questions, feel free to email us, as well as comment on this video, and make sure to sign in for each video that you watch. Thank you very much, and study well.